the normal curve, the areas under the normal curve. The seventh relationship looks a bit complicated. It looks a bit complicated. We can see the value here. Let me even read the description first before we split it and see how we can easily come out with our z-score with our area covered under the curve. If one moves, oh, what is happening? If one moves, let me pick the pen again. If one moves 1.645 standard deviation units, if one moves 1.645 standard deviation units from the mean to the right, the area covered is 0.4500 or 0.4500, the same thing. Likewise, that means we have taken one stand to the right direction, to this direction, the right direction. Likewise, if one moves 1.645 standard deviation units to the left direction, in the decreasing direction, the area covered is the same. Remember I said whether to the left or right, you will still have the same area covered. But in checking this, you may not easily get the z-score on the table. We have to do some small calculations. So we need to follow some steps to get the z-score, to get the answer. There's the value on the table. So when the standard deviation values, I mean the number of units we are moving, has more than two numbers in front of the decimal. It has more than two numbers in front of the decimal. So you can see the value here. We have in front of the decimal, we have 6, 4, and 5. They are more than 2. The 6 is 1, 4 is 2, the 5 is 3. We can see they are more than 2. The first thing to do is the standard deviation units. So we are considering the standard deviation units 1.645. The first thing is the standard deviation units 1.645 will be splitted into 2. And the splitting will be 1.6. And we know that since the decimal places are more than 1, we will see how in splitting it, we have to now start with 0 in front of the whatever values we take from the 1.6. So it will be 0.045. Because we know if we add 1.6 to 0.045, we are going to get the same value. So splitting this into 2, you have 1.6 at one side and you have 0.045 at another side. Let's take notes. So don't forget the 0 in front of the 45. The next step is the 0.045 will be approximated to the 2 standard deviation units, 2 decimal places, 2 decimal places. And converting or approximating 0.45 to 2 decimal places will give us 0.5. That is in 2 decimal places. So on the vertical axis, on the summarized table, on the vertical axis, you choose 1.6. Remember when it was just 1 decimal place, like when it was 1 standard deviation unit, 2 standard deviation unit, 3 standard deviation units, we were choosing from the vertical side. So in this time around, we are going to choose 1.6 from the vertical side. On the horizontal axis from the top, you will choose both the approximated number and the number that comes immediately before the approximated number. So the approximated number will be 0.5. And the number that comes immediately before the approximated number will be 0.4. So you choose the 2. You choose the values under the 2 that correspond to 1.6. So the next step is choose their corresponding values in the table. You choose their corresponding values in the table. Then the last stage will be you add their corresponding values and divide by 2. You add their corresponding values and divide by 2. So now let's explore. Let's go to the table and see how we can do this. This is our table. Remember I said after splitting into 2, from the vertical axis, you will target the 1.6. This is our 1.6 value. The 1.6. Sorry, I've covered the 1.72. So let me take it again. 1.6. The 1.6. Hey, it's not easy to capture only the 1.6. 1.6. Okay. Let's assume I've captured the 1.6. And the approximated number is on the values on top, the horizontal values on the horizontal axis on top. Where do we get the approximated number? Remember the approximated number was 0.5. And the number which comes immediately before the approximated number on top is 0.4. 0.04. And the other one, sorry, 0.05 or 0.05 and 0.04. Now we have to search their corresponding values that match the 1.6 from the vertical side. So here with the 0.4, we can see that the value that matches it will be 0.4495, and then with the approximated value 0.05, the value that matches it to the vertical number, the vertical value 1.6, will be 0.4505, 0.4505, 0.4505. So what we have to do is, let's go back to the previous slide. This is the values we saw on the table, the values, the corresponding values. The first was 0.4495, and the one under the 0.05 was 0.4505. So the next step is I said, after choosing, you have to add the corresponding values. That's the last step, and after divide by 2. So this value, the 0.4495, will be added to the 0.4505. So 0.4495 plus 0.4505 plus 0.4495, and this will give us 0.900 after we have to divide by 2, and dividing by 2 will bring us to the value 0.4500. On your calculator, I know you will get 0.45, but because we are working in 4 decimal places, so you have to add 4 zeros to it. Okay, so this is the information we have here. This is the information we have here, 0.4500. You can see this wasn't directly obtained from the table, so we have to follow the steps. Anytime the values in front of the standard deviation units exceed 1, I said we have to check, we have to follow the steps I've presented. So you follow the steps to arrive at your z-scores, your z-values, the areas you have covered. Okay, I hope you've understood the 7th relationship too. Like I said earlier, this looks a bit technical, but it's even easier than the previous ones. Okay, now let's move to the 8th relationship. The 8th relationship. The 8th relationship. The 8th relationship is also two-tailed. And remember, anytime it's two-tailed, we don't stress ourselves. We first find the one tail, and the answer we get, we add it to itself. So since the one tailed for movements in 1.645 standard deviation units led us to 0.4500 z-score. I mean, the value we obtained was 0.4500 after doing the splitting and adding and dividing. You have to add the number to itself. So adding this to itself will give us 0.900. Because it's in 4 decimal places, you have to write 4 zeros, okay, to ensure consistency. Okay, so that's how we're able to get the value here, 0.900. Now let's move to the next slide, the 9th relationship. The 9th relationship. The ninth relationship is also a bit easier than the previous one, because you can see this fall within our category, our classification. I said anytime the standard deviation units are more than the numbers in front of the decimal are more than 2, like what we did previously. But here we can see they are exactly 2. So if it is 1 or 2, you can get it straightforward from the table. But if it is more than 2, like we did previously, that's where you do the splitting and adding and dividing. But this time round too, we have it exactly falling within our category. So we can get this 2 from the table. We can get this directly from the table. If one moves, it's still one-tailed. Remember I said anytime it's one-tailed, we check from the table. So let's check from the table. Now the description. Relationship 9, one-tailed. If one moves 1.96 standard deviation units from the mean to the right, the area covered is, I'll still use the decimal. The area covered is 0.4750 or 0.4750. Likewise, so we've considered for the right direction, the spaces we have covered moving towards the right direction when we move 1.96 standard deviation units. So if we move, so let's consider the other side. Likewise, if one moves 1.96 standard deviation units to the left, the area covered will also be 0.4750, and that is moving towards the left direction. So the spaces covered here will give us the same value. Remember, I've already explained this, and I said anytime it's one-tailed, we should go to the table. So now let's go to the table. Let's go to the table. But before, we need to also consider these steps. I hope these steps will help us in choosing our values from the table. When it was just in one decimal place, you get it directly on the table. But this one, you still get it directly on the table, but we still need to do some splitting. The first step is the standard deviation unit, which is 1.96. 1.96 need to be splitted into 2. So we split it into one decimal place. And in one decimal place, we know if we were to separate the 6 from the 1.9, that means the 9 there will be replaced with, the 9 in front will be replaced with 0. So meaning we will have 0.6 here. So it will be 0.06. So in splitting, we will have 1.9 at the vertical side, and below the top horizontal titles, we cannot, no, even on the horizontal title we can get 0.06. We can get 0.06. So this on the vertical axis we have 1.9. On the horizontal axis we can also set for we can get the 0.06 there to be able to help us get our corresponding value. Choose their corresponding values, and this is what we are going to see. Let's see. On the vertical axis we have 1.9. We can see our 1.9 on the vertical axis. This is the 1.9. And now the horizontal axis, this is our 0.6. What is their corresponding value? Now let's trace and see. Sorry for my crude drawing. I know it's not straight, but we can still trace the value. Below the horizontal axis too, we can see, so it will be marked there, and we can see the value here. Let me clean it for you to see the actual value. The value here, the where am I? 0.4750 will be the corresponding value. So this is when you move in 1.96 standard deviation units, the area we cover, the area covered, whether to the left or to the right, whether it is an increase or decrease. I've already explained that. Okay, so this is the 9th relationship. Now let's go to the 10th relationship. The 10th relationship. The 10th relationship. The 10th relationship is also two-tailed. And like we have been doing, anytime it's two-tailed, after you have checked for the one tail, you just have to add the two answers. So since the one tail was 0.4750, you just add another 0.4750, because now we have moved in both directions, both angles. We have moved towards the left direction and towards the right direction. There is an increase and a decrease. In negative 1.6 standard deviation unit to the left, and 1.69 standard deviation units to the right. So you don't have to go back to the table, but you add the two because we already have an answer for the one tailed, and get for the two tailed, adding the two, you are going to get 0.9500. The answer we have here. Okay, we have two more relationships to cover. We have 12 relationships, so we will finish within the next less than 10. We will finish within less than 10 minutes. So let's concentrate. I hope you've understood this part too. Okay, the 11th relationship still under the areas under the curve, the spaces we have covered under the curve. Now a description of the 11th relationship when it is one-tailed. On the summarized table, I'm referring to this. I'm going back. I'm referring to this on the summarized table. We are on the last but one relationship. This one. No, the also is not part. Let me clean this. I'm referring to this one. This two is complicated, so we will follow the steps. Okay, so back to the 11th relationship. The 11th relationship. If one moves 2.575 standard deviation units from the mean to the right, the area covered will be, I said let's concentrate on the decimal, 0.4950. Likewise, if one moves 2.575 standard deviation units to the left, when there's a decrease, the area covered will be the same, 0.4950. 0.4950. Okay, now since it is one-tailed, I said anytime it's one-tailed, we search from the table. And this time around, the values in front of the standard deviation units, the decimal places are 3. I mean, in front of the decimal, we have 3 values. And so we have to follow our steps. Okay, the first step is the standard deviation units will be split into 2. Remember this. And here we have 2.575. Splitting this into 2, we will have it this way. We have for the vertical side, we will get 2.5. 2.5. And for the horizontal side, we are not going to get this value there because the values there are in 2 decimal places. So let's do the splitting first and see. In splitting this, we need to put 0 in front so that we can cater for the last 2 values. That is 0.75. When you want to consider this, the 5 there will be treated as 0. That's why I've brought 0 here. Okay, so in splitting this into 2, we have 2.5 and we have 0.075. Now the next step is the 0.075. Since on top we have all the values in 2 decimal places, so you can't trace 0.075 there. So what do we have to do? We need to approximate it to 2 decimal places, which will give us 0.08. 0.08 can be traced from the horizontal axis. So on the vertical axis, you choose 2.5. On the horizontal axis, you will choose both the approximated number, which is 2.5, and the number that comes immediately before the approximated number, which is, so we have chosen the approximated number already, which is 0.08. The number that comes immediately before the approximated number will be 0.07. So you choose these 2 numbers. You will check their corresponding values to the 2.5 from the vertical side and add and divide. You remember that procedure? Okay, so let's go to the table. So before the table, I said the last but one step will be choose the corresponding values. I've already said this. And you add the values after you divide. Now let's go to the table and see the practical aspect. Are you ready? Okay. On the table, from the vertical side, we have our 2.5 here. And remember the splitting and the approximated value. The approximated value was 0.8. Here's the 0.8. The number that comes immediately before the 0.8 is 0.7. 0.7. So this number. So we are going to search beneath the 2 values. We are going to search below the two values, and the correspondence of the two values can be traced from here. We have the first one under the point 0.07 to be 0.4949. Under the point 0.08, we have 495051. Sorry. So now let's come back to this slide. Under the point 0.07, we have 0.4949. Under point 0.08, we have 0.4915. What I said is, we will add the 2. So adding the 2 will give us this value. Then we divide by 2, and we will arrive at the z-score of 0.4950. 0.4950. Or you can say 0.4950. Okay. So now let's go to the two-tailed. That is our last slide for the third session. The 12 relationship is two-tailed. If one moves 2.57 standard deviation units from the mean, both to the left and right, both to the left and to the right, both to the left and right, the areas we have covered, or the spaces covered, the area covered will be 0.9900. Remember I said after checking for the one-tailed on the table, you have to now add the value to itself to get for the two-tailed. So adding the value we got was 0.4950. 0.4950 to itself will give us, 0.4950 to itself. I mean, because we are treating both sides, will give us what? Now, the value we will get is 0.9900. Confirm and let's see if it's right. So I added the 2 because we know for one side, either for the left or for the right. And whether left or right, you get the same value. Okay, the negative sign is just direction. So this will give us 0.9900. And here in percentage wise, this means that we have covered 99% of the spaces. And let me draw your attention to something. Remember when I was explaining the features under the normal curve, I said with standardized normal distribution table, with the standardized normal distribution curve, anytime the normal distribution curve is standardized, the standard deviation is always 1. The standard deviation is always 1, and the mean is 0. And the area covered under the curve is always 1. If the area covered under the curve is 1, then this will mean that we have 0.5 for both sides. We have 0.5 for both sides. Yes, if we are splitting the graph into 2, the curve into 2, and we already know that the curve is symmetrical. When we divide it into 2, you have 2 equal halves. So meaning each half will be 0.5, 0.5. So if after covering both sides, the value is 0.49 for one side, for either side, that means for the total area under the curve, which is 1, which in percentage wise we are going to get 100%. We have covered 99%, and for the other side we will cover what? 0.49. Sorry, we will cover 49.50%. Okay, thank you for listening. Now let's go to the last slide. That is the session review. The session review. An area of 90 is covered by, we learned that an area of 90 is covered by 1.645 standard deviation units to the left and to the right of the mean. We've learned this. And we've learned how to even search for the values for both the one-tailed and two-tailed standard deviation units. An area of 95% is covered by 1.96 standard deviation units to the left and to the right of the mean, and the area of 99% is covered. Remember, the total area under the curve, I've already said is 1 in percentage wise. 1, when you convert it to percent, it will be 100%. So if we are taking both sides, it will be 99%. We've not covered the entire space. Standard deviation units to the left and to the right of the mean too has been treated. Thank you for listening. Please don't still hesitate to call me for further clarifications. If you don't understand anything, you can call me or WhatsApp me. Thank you for listening.